Question 10, matching. Given a line passes through A 5, negative 8, B 2, negative 2, C negative 1, 4, and D negative 3, 8. Right triangles are formed using the line CD and AB for respective hypotenuses. Prove that FC divided by FD, so FC divided by FD is equal to the distance of EA divided by EB. This will prove that the slopes of AB and CD are the same slope. Alright, read the following proof for this problem carefully and then follow the instructions. So the points A5, negative 8, B2, negative 2, C, negative 1, 4, and D, negative 3, 8 are all on the same line. That is given. FD is equal to 4, EB is equal to 6, blank 1. Alright, well, FD, they found that distance. So blank 1, I'm gonna look for the distance formula. So distance formula. Alright, and we're looking at point F is at negative 1, 8, and E is at 5, negative 2 are constructed to create triangle CFD and triangle AEB respectively. Intersection of blank line segments. So points F right here and point E. So they're intersecting the vertical and the horizontal line segments right there. That's how they created that point E, is they came down vertically and they went across horizontally, and where those two met, that is where the points were created. So blank 2, we're looking for vertical and horizontal line segments. So blank 3, we have to figure out what they're saying here, and the reason is the vertical and horizontal lines are perpendicular. So we're going to look for FC perpendicular to FD. That is following very nicely because we were talking about intersecting vertical lines and horizontal lines. Well, the vertical line is FD and the horizontal line is FC, and that is perpendicular. The vertical line is EB and the perpendicular line, horizontal line is EA. That is perpendicular, and that does create a right triangle. And also I'm using the clue from statement 5. Angle F is a right angle and angle E is a right angle. So I'm using the clues that they're talking about this F and this E, and so the vertical line to create that and the horizontal line to create that would be our FC is perpendicular to FD and EB is perpendicular to EA. And then definition of perpendicular. So blank 4 is the statement and it's the right angle theorem. And so blank 4, angle F is going to be congruent to angle E because right angles are always congruent to each other. So I'm going to use that. And then and if I didn't know what that was, I could take this and I could say, okay, what is the right angle theorem? And I'm just Googling it. Right angle theorem. I'm going to just hide it in. It says if two lines form at a right angle, then these lines are perpendicular. If two angles, any two right here. Any two right angles are congruent. Alright, so we knew then that we have congruent angles just like we matched. Alright, so now let's keep moving. EA is equal to 3, FC is equal to 2, EB is equal to 6, FD is equal to 4. That was the distance formula. So then we have blank 5 is equal to 3 halves, and E over FD is equal to blank. Okay, well, first off, I'm going to look at the next line to see, I wonder what they used here. So blank 5 should be EA over FC. Now if I didn't think to look ahead, then I could go like this. Okay, EB. Well, EB is the vertical one, so what's the vertical one in the other triangle? F. Okay, time out. They're using the vertical to the vertical. So EB divided by FD. That is what they were comparing. They compared vertical to vertical. So then we should have a horizontal, EA to horizontal. That's what we've been talking about. So let's find that for blank 5. And if you notice that I had to pause and think about what was happening in this statement, and that's completely fine, because you can either use the clues by looking at the statements ahead, or you can look at what are they giving me so I know what should be compared next. And also another clue is they gave us a 3 and a 2 there, and I'm looking ahead. Well, EA was 3 and FC was 2. Is that what they're asking? They wanted horizontal compared to horizontal, and then they wanted vertical compared to vertical. Yes. So blank 5 is going to be EA over FC. And we're going to go right up here. Blank 6, 6 divided by 4, that's EB. EB's distance divided by 4. Now that does reduce down to 3 halves, so I'm glad that they include that. 6 divided by 4 is equal to 3 divided by 2. Alright, so now moving on, EA divided by FC, which was 3 halves, equals EB over FD, which reduced down to 3 halves, and that's the transitive property because they both equaled 3 halves. Blank 7, given the side angle side similarity theorem. Alright, I know that side angle side has to do with similar triangles, so blank 7, I'm going to look for anything that has a similar triangle, and that is the statement. The one that says similar triangles right here, that's a reason. So we wanted a statement because it was in the statement column. Alright, so then FC divided by FD is equal to EA divided by EB. The ratios of corresponding sides of blank are proportional. They wanted similar triangles. The corresponding sides in similar triangles are proportional. So that is what goes in blank 8. And we'll come here and we'll check it. And it says, great job. All right, so 9 is another proof, and I'm just going to scan. I want to make sure that we have a few of enough time for one of these. So we'll jump to question 9 since it is a proof, and those tend to be the hardest. So a line passes through A37, B24, C0, -2, and D, -2, -8. Right triangles are formed using CD and AB for respective hypotenuses. That's what they're talking about, hypotenuse. Prove the rate of change from point A to point B is the same as the rate of change from point C to point D. Okay, so they want to prove that the slopes are the same. That is another word for slope, rate of change. Okay, so it says read the following proof for this problem carefully and then follow the instructions. It is given that points A 3, 7, B 2, 4, and C 0, -2, and D -2, -8 are on the line. Point F is made by the intersection of the vertical line through point D and the horizontal line through point C. Likewise, point E is made from points A and B. So it's just saying point E and point F are made because the vertical line and the horizontal line intersect. So using the blank one, it can be proved that FD equals 6 and FC equals 2. Similarly, it can be shown that EB equals 3 and blank 2. Okay, so they're finding distances for FD and FC. So I would say blank 1 is the distance formula, and they found that EB was 3, so I'm assuming they want to know what EA's distance is because they found the vertical and the horizontal for FD and FC. So we want to know both of those distances. So EA is 1. So in blank 1 we're looking for distance formula, and blank 2 we're looking for 1. So blank 1 distance formula, blank 2 EA is equal to 1. Alright, now moving on, we'll scan this. Because FD is a vertical line segment and FC is blank, FD is perpendicular to FC. Well, what is FC? FC is horizontal, so blank 3 is horizontal. Alright, so FC is a horizontal. That means that FD and FC are perpendicular. So these two are perpendicular, which means they have a right angle. Angle DFC, so angle from D to F to C. That is the angle that they were talking about. And similarly, BE is perpendicular to EA, so angle BEA is a right angle. And using the right angle theorem, it can be shown that blank. Well, what angles were they talking about? They were talking about angle DFC and angle BEA. Since they're both right angles, that means they are congruent to each other. So let's look for it can be shown that they're congruent. So now this says angle BAE and this one says angle BEA. Does it matter? Yes. Let's look at angle BAE. So the direction of it does matter. So angle B to A to E is talking about this angle right here, which is not the angle that they were referencing. Now the other one lists B to E to A, and that's the 90-degree angle that we were looking at. So the order of angles matters, and it tells you exactly the order that they want that they that it goes in. So blank 4 is going to go BEA. So the ratio of FD to EB, so FD is a vertical and EB is vertical. Okay, so those are corresponding sides in a triangle. So that ratio is 6/3. That's the distance of FD over the distance of EB, which reduces down to 2. So blank 5 is 2, because that's what it reduces down to. The ratio of FC, which is our horizontal, to EA, which is the horizontal, is 2 as well, because the ratios of corresponding side lengths are of the adjacent sides of both triangles are blank. Well, the ratios, this one reduced down to 2 and this one was 2. So the ratios are the same or congruent. So blank 6, we're looking for the same. All right. And the included angles are congruent. Then triangle DFC is similar to triangle BEA by the side angle side similarity postulate. So they had the vertical sides were proportional, so vertical sides were proportional, and they had that included angle. That's where the angle came from. And then the other side was the horizontal side was the same proportion. The horizontal sides were the same proportion to the vertical sides. All right, so because the triangles are similar, their corresponding parts are proportional. Therefore, EB, it divided by EA, so EB right here, EB, the vertical distance divided by the horizontal distance, that is slope, rise over run, is equal to FD, vertical distance, divided by FC, which is our horizontal distance. That is a slope as well. But I'm figuring that they want to know that the actual number. So EB was 3 and EA was 1. So 3 divided by 1 is 3. And since we have proportionality and since we have similarity, we know that the rise over the run for the for FD over FC is going to be the same. So blank 7, I'm looking for 3. Because EB over EA is equal to the rate of change from point A to point B, that's because it's the vertical distance over the horizontal distance. And FD over FC is equal to the rate of change from point C to point D. Again, it's the vertical distance divided by the horizontal distance. It is now shown that the rates of change are blank. They are, is it increasing, proportional, or the midpoint formula? What were we trying to prove? Prove that the rate of change from point A to point B is the same as the rate of change from point C to point D. Okay, so we're looking for the same. That was what we were trying to prove. So we might have to go and relook at blank 6. And let's see. Of course, because we want blank 8 to be the same, because that's what we were trying to prove. We were trying to prove that the slopes were the same. So let's go back and read blank 6. So it says, because the ratios of the corresponding side lengths of the adjacent sides of both triangles are blank, and the included angles are congruent. Okay, well, they are proportional. That means they are see how this one is 6 over 3 and the rate, which reduces down, they are proportional. This FDC is just a bigger version of EBA and proportional. So blank 6 is proportional. Submit for grading. So let's go check for 7. Make sure that what we changed was correct. I mean, we were on question 9. Make sure what we changed was correct. There we go. All right. And then another thing that we could do is they used the similarity side angle side similarity postulate. So you could do one of two things. You can go to Google, or you could go to where is it? the key terms and look for side angle side. So right here, key terms. Do they have side angle side? Nope. So another option would be concept C, similar triangles and their slope, and you could go through that, or I find a quicker one is just go to Google and say side angle side similarity theorem, and it says that the side angle side similarity is when two triangles have corresponding angles that are congruent and corresponding sides with identical ratios. Okay, so that is that we have proportionality. So that's another way to use your tools. And then we're going to go, I'll jump to question 5 really fast and we'll go from there. So question 5, a line passes through A35 and B-5, 7. The slope of the line is blank. Which word most accurately completes the previous sentence? Okay, well, I'm going to do this by observation. So I'm just looking at this slope because the options are negative, positive, undefined, or 0. So I'm thinking in my head, okay, well, negative slope is decreasing as it moves from left to right. Positive slope is increasing as it moves left to right. Undefined, sorry, those were a little bit big. Undefined is vertical, straight up and down, and 0 slope is a straight horizontal. So the reason I can remember that is because I made an analogy to myself. So negative slope is like you're running down a hill. So does that look like you would be running down a hill as you were looking from it from left to right? So as I look at this from left to right, which direction am I running? I'm running down. Positive, if I started from the left side of this and I move to the right side, I'm running up a hill. So, and then undefined, well, there is no left and right on this. I'm looking straight up at a sheer cliff. And then 0, I have no hills. So that means I'm not going up or down. I'm just 0. And so I just made analogies. Negative was running down a hill, positive's running up a hill, undefined's looking straight up at a cliff, so you would look straight up, and 0 means I am running on flat ground. So I'm looking at this and I'm saying, okay, if I start on the left side and I move, follow that line, I'm moving down. So it's negative. And then question 4, you can use the same analogy if you would like. Okay, consider the two points A97 and B52. What is the ratio of the vertical change from A to B to the horizontal change from A to B? In other words, what is the slope? Yep, the slope is the vertical change or vertical distance compared to the horizontal change or horizontal distance. So our slope, what is our vertical distance? Well, vertical is represented by the y-axis. So I'm looking at the y change or y distance. So the distance is you take your two coordinates and you subtract them. So 7 minus 2. And then compared to, so divided by, the horizontal change. Horizontal is our x's, so I want my horizontal distance. So 9 minus 5, and that's going to equal 7 minus 2 is 5. That's our vertical distance compared to our horizontal distance, 9 minus 5, which is 4. So that's what I'm going to type in, 5 divided by 4. And then I'm going to do question 2 again. How is the slope ratio 3 to divide by 4 correctly interpreted. Okay, well, slope is our vertical distance compared to our horizontal distance. So since they're both positive, they're both increasing. So I'm looking for both increasing, and 3 is our vertical and 4 is our horizontal. So for every 3 units of vertical increase, there is a corresponding 4 units of horizontal increase right there. All right, and we're going to check these. To double check. And we'll see. All right, question 5, correct. Question 3, correct. And question 2, correct. All right, if you have questions on the other ones, please feel free to contact me or fill out a request for help form or attend the live office hours. Hope that helped.